this video, we're going to start our nomenclature with cycloalkanes. Now, these cycloalkanes are just going to be basic alkanes with like one or two substituents attached to them, right? So they're not going to have any double bonds or anything too weird. So let's begin. If you have just a basic molecule with no children on it, with no substituents, then you could just say it is as follows, right? So let's say you have like a 3-carbon molecule is going to be looking like this. The reason why it's a cycloalkane is because it follows the formula of CnH2n, right? So that means that there are 3 carbons here, so it's going to have C3. That means we're expecting, what? 3 times 2 is 6 hydrogens. So 2, 4, 6. That makes sense. So we have, if you can't see it, it would have a hydrogen right there. These are hydrogens, hydrogen, and another hydrogen pair right there. So, yeah, it's a dog. So it's like, I mean, that's just a cyclical formula. If you're asked to draw a cyclic compound, or if they give you something like C4H8, you would know that you have to do it in a cyclical fashion, right? So you know this was random, but let's do it, right? So how would you do this? Well, if you have 4 carbons and they have to be in like a cyclical fashion, just do a square, right? So 2, 4, 6, 8. That's 8 hydrogens. This would actually be called cyclo. Let's see, butane. So whenever you have CnH2n, you're going to have your cyclo, and then the parent name. So these are 4 carbons, so that's a butane, but it's in a cycle. So you say cyclobutane. For our dog right here, we're going to say cyclo, let's see, 3 carbons. Oh, 3 carbons, that's propane. So cyclopropane, right? Okay. And you can also do, let's do 5. C5H10. Let's do that. That'll be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yeah. So it'd be 2, 4, 6, 8, 10. 10 hydrogens right there. And that would be called a pentane. And this would be 1, 2, 3, 4, 5, 6, 7. Or 1, 2, 3, 4, 5, 6. 6. Sorry, 6. This would be cyclo. Can you guess it? Hexane. So if it's just by itself with no children, then it's pretty easy to do. Just cyclo and then what? The parent name. In this case, there are 4 carbons. 4 means butane, so cyclobutane, cyclopentane, cyclohexane, right? Cyclopropane. However, if you have a ring with 1 substituent, then you're going to have to name that substituent, right? So for instance, you have what? Let's make this up. Okay. Let's say you have this, and this is what? A bromine, right? So instead of saying, you know, like, oh, this is 1 bromo hexane, whatever, we just say, oh, this is bromo. What else? Cyclo. And I put 1, 2, 3, 4, 5, 6 carbons, so bromo cyclohexane, right? And it doesn't matter if it's like this. It's still going to be bromo cyclohexane, because if you were to get this molecule and, like, you know, rotate it, then the bromine would actually be over here. Everything else kind of rotates with it, so it would still be bromo cyclohexane, right? So therefore, since you can rotate it and it's still going to be the same, if you have a molecule kit, I recommend that you do this. It would be a bromo cyclohexane. So if it's only just 1 substituent, like a halide or a methyl, just say, you know, methyl cyclohexane, bromo cyclohexane. You don't have to specify what carbon it's on, right? We don't say 1 bromo cyclohexane. It's always going to be 1 bromo cyclohexane because it rotates. Alright, and now we have this Teletubby looking molecule, right? And we have to name it. So you see a Y, right? You see a Y. And whenever you see a Y, that's going to give like an iso, right? And now we just got to find out which iso it is. Let's see here. Let's see. It's going to be 1, 2, and 3. So 3 means propane, right? So it's going to be isopropyl. Because that isopropyl, normally it would be called isopropane, but that isopropane substituent is being connected to that parent molecule. So to do that, we have to get our carbon and rip off a hydrogen. So now that N carbon right here is going to have like 2 hydrogens and 1 empty space. And that empty space is going to allow us to actually combine with this parent molecule. So it's going to be a propyl, right? Again, propyl or YL just means that we ripped off a hydrogen from that carbon. So we could play Legos and connect, right? So this is an isopropyl. It's a Y. A Y means iso. And then 3 carbons, propane, isopropyl. Okay. So if you were to rotate this, then you would have like a molecule that has something like this. Really bad at drawing. Well, it'd be like, and then you have your isopropyl over here. Because everything else rotates. I'm not really good at drawing, but everything else will rotate, and therefore it's always going to be on the first carbon. And if it's just one substituent, like this whole thing is of one substituent, then you don't have to name the location. You could just say isopropyl cyclohexane. Right? So that's isopropyl cyclohexane. You don't have to name the location. You don't say 1-isopropyl cyclohexane. You don't have to do that, because it's always going to be on the first carbon, no matter how you rotate it, how you twist it, how you turn it. So it's going to be on the first one. So you can omit, you can drop out the location. Okay, but what happens when you have one ring, right? One ring, and you have 2 substituents? Hopefully you can see by now that this is going to be our parent ring, right? That's a 1, 2, 3, 4, 5, 6 hexane. And we're going to have a methyl. And let's see, 1, 2. 2 carbons mean that it's an ethane. So we're going to say methyl and ethyl. Great. So how do we name this? Do we start numbering from here, 2, 3? Or do we go the other way? Do we go 1, 2, and 3? Well, if you have 2 substituents, and they're both alkanes like this, right? They're both basic. Well, you start at the one from the alphabetical order. So E comes before M, right? So that must mean that we're going to number from here. Are we going to number from right to left? Well, if we do that, then my methane is going to be on 5. But what if I go on the other side? What if I do 2 and 3, 4, 5, and 6? Right? Well, my methyl is going to be on 3, and it's better for it to be on 3 than it to be on 5, right? We always want the substituents, the children, to be on a lower number. So I would rather have a methyl on 3 than a methyl on 5. Therefore, we can say that this molecule is going to be called a what? It's going to be a 1. Location, child, ethyl. Location, 3, child, methyl. Location, we have no other locations, so we're just going to say parent. So cyclo, hexane. Ran out of room. But yes, if you have one ring and 2 substituents, 2 children, and they're both alkanes, right? So there's no double bonds or triple bonds, right? Then you would have to do alphabetical order. You would have to number starting at the one that starts from the alphabet. Sorry. So that was pretty sloppy, but since ethyl comes before methyl in the alphabet, we're going to start counting from that and then count towards the other substituent. So we're not going to count the long way, we're going to count the short way towards the other substituent in our parent molecule. Okay, but what happens if we have one ring and we have 3 substituents. Well, do we start counting from the ethane? Well, or do we start counting from the chlorine, the chloro? Now, normally you'd be saying, oh, we're going to start counting from chloro because, well, C comes before E, and E comes before M, right? But that's not right. See, IUPAC standards say that you should be naming, well, you should start counting from the substituent that gives you the lowest number. So, for instance, you can say 1, 2, 3, and 4, right? And hey, that's pretty good, because if I do the other way, I could do, 1, 2, 3, 4. I could do 4 like that, and 5 and 6. So which one is better? Which one is better? You're probably wondering, I'd probably start at the chlorine, right? Well, not really. That's not good. Because the ethane is going to be the largest compound. It's going to be the largest child. And technically, the ethane is going to have a little bit more importance because it's older, it's bigger than chlorine and a methyl. And so I'd rather have that methyl or that ethane at the lowest number, right? It's really confusing, but again, it comes with a lot of practice. Even I have to practice this. It's really complicated. So I'd rather go 1, 2, 3, and 4, right? But then you're probably saying, why can't I start at the ethane if I want it to be the lowest? Well, do you? 1, 2, 3, 4, 5. Chlorine at 5? Really? No, I don't want that. What about the other way? 1, 2, 3, 4, 5, 6. Methane or methyl at 6? No, that's pretty bad. I don't want anything past like 4. That's terrible. Just do 1, 2, 3, and 4. Then 5, 6. So because ethane is bigger than methyl, or because ethyl is bigger than methyl, and it's technically bigger than chlorine, because in ethane or in ethyl you have 2 carbons, and 2 carbons are slightly bigger than chlorine. So technically ethyl would have a larger importance in this molecule. So we're going to try to keep it at its lowest number. And again, it comes with a lot of practice. So we're just going to say this is a what? This is a 1 methyl. This is a 2 ethyl. That's a 2 ethyl. This is a 4 chloro. And the whole thing is a hexane, or a cyclohexane, right? And so now we will combine all the children and bring it to their mom, to their parent. So we do this alphabetically. We start like 4 chloro, 2 ethyl, 1 methyl, cyclohexane. Cyclohexane. Hexar. So, yeah, I'd rather have ethyl, which is the biggest one, to be on the lowest number. And with that logic, we're just going to say 1, 2, 3, 4, going clockwise. And then after we gather our children, we're going to name them alphabetically. So 4 chloro, because C comes before E in the alphabet. And then 4 chloro, 2 ethyl, 1 methyl, cyclohexane. Right? Okay. So for this molecule, notice that we have a what kind of ring? We have a cyclo. 1, 2, 3, 4, 5, and 6. We have a cyclohexane. A cyclohexane. And hey, what kind of friend do we have? Well, it's a T-shape, right? It's a T-shape, but let's count the carbons. 1, 2, 3, and 4. This does not count because that's connected to the bond, to the parent molecule. So we have a 4 carbon substituent, and it's in the T-shape. So can you say what kind of name it is? It's a tert-butyl. Yeah, because 4 means butane, and it's in the T-shape, so you could say tert-butyl because this carbon is actually going to be attached to 3 other ones, right? So technically it's not a tertiary carbon, but we're going to say that it is, right? So it's attached to 3 other carbons, and it's in a T shape, therefore it's a tert-butyl. And if you were to rotate this molecule, no matter where you rotate it, it's always going to be on the same carbon. So technically it could be like a 1 carbon, right? So if you're counting from here, which you will, 1, 2, 3, 4, this is on the first one, and since it's the only substituent in the molecule, you don't have to say the location because it is the only substituent in the molecule. If you had 2 tert-butyls, then yes, you would have to say the location for it. But in our case, it is the only substituent, so we just leave it alone. So instead, we just say tert-butyl cyclohexane. Okay, so can you name this molecule? Well, yeah, it's pretty easy. Realize that this is going to be a cyclohexane. So we're going to say cyclohexane. And what about the substituent that we have? Well, let's say this one does not count, right? So don't make a mistake of that. Don't say that as part of this substituent, right? Don't say that. That's 1, 2, 3, and 4. This molecule this carbon does not count, right? Because it's actually attaching us to the parent. We want the child by itself, and don't take that out of context. So that's 1, 2, 3, 4. That's 4. So this is a butyl, right? And if you were to rotate it, you would get the butyl in the same location. So technically, you can start counting from here: 2, 3, 4, 5, 6. It's always going to be on the first carbon. Because it is the only substituent in this molecule, we do not have to list the location. So we can simply say that this is a what? A butyl, no hyphen, cyclohexane. Alright, so in this molecule, this is a pentane because it has 5 rings. It looks like a pentagon, right? Not 5 rings, but 5 carbons. And yeah, we're going to put, what? We're going to say, 1 chloro, 2 hexanol, whatever. No, we don't do that. That's very haphazardly. Don't do that. Realize that whenever it's just an alkane or a halide, that compared to them, alcohol is going to be your favorite child. Alcohol is going to be your favorite thing, right? So it's going to be more important. So whenever you have a cyclo molecule with an alcohol in it, start numbering it from there. Start numbering it. So 1, am I going to number going this way? No, I'd rather number going this way. 3, 4, and 5. Right, because alcohol is super important. So we're going to put it on the lowest number possible. Okay. So we realized that this is actually a pentane. So we're going to say right here, we're going to say 2 chloro. Say 2 chloropentanol, right? Or you can say 2 chloropentan 1-ol. And now that I think about it, it would actually be like this. My mistake. It would be like this. 2 chloro 1 pentanol. Right, because this one would actually kind of merge between it, and then these would combine. So, I mean, I'm not sure which method you prefer, but it might show up on your exam wherever you're taking it. So 2 chloro could be 1 pentanol or 2 chloropentanol, or 2 chloropentan 1-ol, right? This is no gap between it. I just messed up and added a hyphen. So don't add hyphens like that. So again, alcohol is going to be super important. You're going to put it on the lowest number possible, and then move upwards in this case, because the next substituent needs to be on the second lowest number. So it could be 2-chloro-1-pentanol, or it could be 2-chloropentane 1-ol. Alright? Now that we know the basics of cycloalkanes, we can actually move on to bicyclic alkanes, or bicycloalkanes. So a bicyclic alkane is when two rings merge together and they share a common carbon. So for instance, we can have something like this, if I can draw it correctly. Well, that was really bad. So it's going to look like this. Alright, so if you were to number this, if you were to number it, you would start like 1, 2, 3, 4, 5, 6, and then 7. If this is not obvious to you, then I can write it out. I could blow up this image. I could say C, C, another one. Let's try to do it like this, and then kind of like a C right there. Alright, so let's connect these. We have this, and it's kind of like a 3D model, right? So the ones that I just finished connecting, they're on the table, and then this one is kind of like facing you. It's kind of jumping out at you. And I can also put this on the table. I can make it like a flat model, right? Make this a flat model, so I could do this. Right? And then, see? So this would be a carbon right here, a carbon, another carbon, a carbon, a carbon, another one, and then kind of another carbon just peeking outwards. So this is actually how we name it. How we name it is going to be what? We have 1, 2, 3, 4, 5, 6, 7 carbons. So this is a 7 carbon, and 7 means hep, right? So you're going to say heptane. But they are actually 2 rings connected to each other. And 2 means bi, right? So we're going to say bi, which means 2. Cyclo, cyclo, and then how many carbons do we have? 7. So we're going to say heptane. So on the exam, it could be given to you in pink, where it's kind of like this crook, right? Or it could be given to you in green. And if it's in green, you're going to have to label the carbons, because I personally find that pretty helpful for me when I'm doing bicyclic nomenclature. So since it has 7 carbons, you're going to say heptane. And since it is two rings merged together, you're going to say bicyclo. So bicycloheptane, right? Okay, so now we're going to go into the anatomy of this. We're going to go into the anatomy and say that this right here, this carbon and this carbon right there, they are called bridgeheads. Because if you were to look at this, it kind of looks like the San Francisco Golden Gate Bridge, right? So this carbon only has 1 bridge. So that is a 1 carbon bridge, right? And if you really want to get specific in this, right? If you really want to get the proper nomenclature, this is how you name it. You're going to say this. You're going to say bi, cyclo, bracket. Now the bracket means that we are going to start numbering our kind of like our bridges. So this is a 2 carbon bridge, this is a 1 carbon bridge, and this is another 2 carbon bridge. Okay? So the bracket means that we're going to start numbering our bridges. And the bracket needs to go in decreasing order. So it needs to be the big number, medium number, smallest number. So our biggest number for our bridges, this is not a bridge right there. However, this is a bridge. That's a 1 carbon bridge. So we're going to go to our biggest one. We're going to say 2, period. Do we go right to left? Well, I'm not going to say 2, 1, 2 because it needs to be in a decreasing order. I'm going to say 2, period. I'm going to look at my other bridge. Hey, this has 2 carbons. This only has 1 carbon. So I'm going to say 2, period, 2. Look at my last bridge and realize, hey, that only has 1 carbon in the bridge. We are not counting the bridge heads. We don't count that. A bridge head is like a carbon that is shared between another ring, right? So these 2 rings share that carbon. So technically these 2 rings share 2 carbons. And this middle child is stuck in the mix, right? He's stuck. So we're going to say 2, period, 2. Our last bridge is just 1 carbon. So 2, 2, 1. No period. Bracket. And to keep with the aesthetic, we're going to make it green. So bracket. What? Bicycloalkane. Right? Let's do another one so you could get more comfortable with the material. Okay. So this looks pretty weird. But actually, it's just 4 carbons. There are just 4 carbons. Why? Let's see. 1, 2, 3, and 4. Notice that you could have gone 1, 2, 3, and you could have gone 2, 3, and 4. I just chose the right side. You could have chose the left side. It's cool. It's fine. Here's the reason why it's 4 carbons and not 5. It's 4 carbons because you have carbon, 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 and carbon. And it's attached like this. Right? That's how it's attached. If you saw a molecule like this, crook right there, look, that is 1 carbon right there. So it would actually end up looking like this. You see? So it would have 5 carbons. It would have this. It would have C, 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 another C, and a carbon kind of like facing towards the sky, popping off the screen. But that's not what we have. We have a straight line, meaning that this carbon is bonded to that other carbon. Okay? So it is 4 and not 5 carbons. 4 and not 5 carbons. Okay, so let's start naming it. So we have a carbon, another carbon, a carbon, and another one. There are 4 carbons, meaning that is a what? A butane. And also, it's shared between 2 rings, so it's going to say Bi-Cycloalkane. Okay, but don't stop there. Do not stop there. You need to add your brackets. Always have your brackets for bicyclical molecules. So you'll have bi, cyclo, bracket. How many carbons do we have on our bridge? We have 1 carbon. We have 1 carbon. So we say 1, period. 1, period. How many carbons do we have on our bridge right here? 0. If there were 1 carbons right there, it would be 1. If there were 2 carbons in the middle, it would be 2. Or actually, it would actually be 2, 1, 1. But we do not have any middle carbons. So it is 0. Alright, do you understand? There is 1 carbon on the edge. We put 1. There's another carbon at the edge. That is 1. There are no carbons in the middle. So it is 0. We are decreasing. We are not increasing. We are decreasing. Decrease. So 1, 1, 0. What? Butane. Okay. But what happens if you have a bicyclical molecule with children? What happens if you have substituents on your bicyclical molecule? Well, I'm introducing the cockroach model. It looks like a cockroach, right? It has like its little antennas and its legs. It looks evil. But it's a pretty good example of what I'm trying to do. When we start naming this, we're going to have to start counting, right? So we begin counting at a bridgehead, right? So we become counting at what? Do we count here, 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 or do we count here or here? Well, when we're talking about bridgeheads, it's only applicable to this carbon and that carbon, because that's like a bridge, right? Hold on. It's kind of like this, right? So, I don't really know how to draw, but this would be a carbon, and this would be a carbon. And what you see right here is a guy who's stuck in the middle. So here's our carbon, and he's like, help. He's screaming for help. And so, that's a bridgehead. This would be a bridgehead. This would be a bridgehead. Because you have like the little gates right there, right? You have a gate right there. But this would not be a bridgehead. And actually what you're seeing here is, this is a methyl, right? So a methyl is stuck in the bridge. So you can say he has like a H3. Or H3, right? So that methyl is stuck in the bridge, and we have to actually name it. So I hope that just kind of makes the image a little clearer for you, right? So let's erase this really quickly. And so when you start numbering this, you want to go directly to your bridgehead, and you're going to pick the longest path, because really you don't like the person at the bridge, so you're going to take your sweet time. You're not going to say, oh my gosh, 1, 2, and 3. No, you're going to take your sweet time. You're going to say 1, 2, 3, 4, 5, 6, and 7. Oh, we're back at the bridge. 8, right? So you kind of want to do a loop, like a circuit off of Mario Kart. You're going to take the longest path, hit the other bridgehead, which is number 5, and then from the other bridgehead, you're going to connect back to the first one. If you have multiple bridges, then you're going to go from 5 to the other bridge, to the other bridge, to the other bridge, and then finally to the first bridge, because you really don't like this person at the bridge, right? Our shortest one is going to be the center, right? It's going to be the number 8. It only has 1 carbon, so that's being last, right? You want to save the person last. You don't like them. Okay, so when you do that, we successfully numbered our cyclical model, and it's 8, right? So we know it's going to be octane, and we know it has to be bicyclical, so Bi-Cyclo, right? Bicyclo, and yeah, this looks kind of weird. You have 2 O's together, so it's like Bicycloalkane, right? That looks really weird because you forgot your brackets. You have to do this. First of all, what do we have here? We have a what? We have a methane. So we have an 8 methyl, right? Because that methyl is attached to the 8th carbon. So it's an 8 methyl. Okay. Then we just put our molecule together. Bi-Cyclo bracket. Now we name it. We have 1, 2, and 3 carbons right there. So we will say 3, because the other one is being what? The other one is 1 and 2. Right? We don't count the bridgeheads. We don't count them. We count the other 2. So 3 versus 2, yeah, I'm going to put 3 first. Period. 2, period. How many are on the bridge? We have 1 person stuck on the bridge. So we will say what? We will say it is a 1. No period. So 3, 2, 1. What? Octane. Yeah. Get learnt. For real. Okay, let's try naming this molecule. So whenever you name this kind of molecule, you want to start at the bridgehead. So this is your bridge right here. And this is going to be your bridgehead. 1 and 2. Now, I usually start from the top, right? You can name it going this way. I prefer... oh, smiley face. I typically start from the top, so I go 1, 2, 3, 4, 5, and 6, right? And then I want to go from the 6th one back to the first one. So notice that I took the longest path, right? That's what you want to do. So we take 7, 8, 9, right? This is a substituent. So from the 6th one, we go back to the first one, right? Okay. So that must mean that we have a what? A methyl on the 8. So we have an 8 methyl. we have an 8-methyl, and we have a 9-carbon parent. So that is nonane, right? So we will say that this is a bi-cyclo bracket. How many on this side? 1, 2, 3, 4. Right? 1, 2, 3, and 4. Well, what about the other side? Let's see it. 1, 2, 3. Right? That is 3. So we say 4, period. Not a comma, period. 3, period. How many are on the bridge right here? None. Right? It's just a bridge. No carbons are stuck in that bridge. So we say 0. 4, 3, 0. What? 0 bracket bicyclo what? Nonane. Nonane. Okay, so what about this molecule? If you can't see in 3D, I recommend that you just rewrite the molecule with the carbon outline. So we have carbon, carbon, another carbon, carbon, another one right here, and kind of like one out here, and then redraw this. So let's see, right there, right? This is attached. This carbon is kind of like pointing towards you, and from this carbon we have a chlorine shooting outwards towards you. So Cl and Cl. Okay. So how many carbons do we have? We have a 1, 2, 3, 4, 5, 6, 7. So it's going to be heptane. It's 2 rings, so we can say bi-cycloheptane. Okay. So now we count from the longest chain that we have, right? Let's count. So we can say this is a 1, 2, 3, 4, 5, 6, and 7. Right? 7. And it doesn't matter if you count 1, 2, 3, and 4, it's still going to be the same thing. Just count from like one of the sides. So the 7 molecule has 2 chlorines. So it'll be 7. 7. Di, because there are 2 chlorines. Chloro. Dichloro. Bicyclo. Right? There's no hyphen. Bracket. Now let's see. 1 and 2 carbons right there. 1 and 2 carbons. So 2, period. 1 and 2 carbons. Right? 2, period. And then 1 carbon. 1. In decreasing order. There are 7, so we say heptane. Alright. How do we name this molecule? If you can't see it, if you cannot see it, then it's actually carbon, carbon, another carbon, like a boat, like a gravy boat conformation. Right? So it's like this, right there, like a metapod from Pokemon. Right? So it is 4 carbons. So if it's 4, we know it's butane. And, well, let's see. Let's make it more complicated. Let's say that this is a chlorine attached to it. Okay, so that's pretty good. We will count from the longest chain. So we say that it is what? It's going to be 1, 2, 3, and 4. We start counting at the bridgehead. It doesn't matter if you said that this is 1 or that's 1, or if you went from left to right. Just count at the bridgehead and you'll be fine. Am I going to go 1, 2, 3, 4? No. Because there's a chlorine, and I want that chlorine to be on the lowest number possible. So I'm going to say 1, 2 chlorine, right? Not like 4 chlorine, I want 2 chlorine. So that is a 2-chloro. We're going to say 2-chloro. Dash. For halides, you add a dash, okay? Bi-cyclo. Bracket. There is 1, period, right here. Let's go on the other side. 1 right there. 1, period. How many carbons are in the middle? 0. bracket butane, because there are 4 carbons altogether. So it is a 2-chloro bicyclo 1,1,0 butane. Alright. If you can't see it, then draw out the carbons. They're out the carbons right here. So this is actually peeking at you. We will have this. We'll have a carbon, another one here, there, and right there. So it's like this. It's like this. This carbon is shooting out towards you. Alright, so now we have 1, 2, 3, 4, 5, 6. So overall it's a heptane. It's a heptane, right? Or not a heptane, I'm sorry. Hexane. Right, heptane's for 7, hexane is for 6. Yeah, 6. Alright. And it's actually shared between 2 rings, so it's a Bicyclohexane. Now we're going to count from the largest chain, and we're going to start at a bridgehead. So where am I going to start? Am I going to start 1, 2, and 3? Well, maybe, but what about 1, 2, 3, and 4? Ah, you see? 4. 5, and then the last one, 6. Right, so we start at the longest chain, which was from left to right. So 1, 2, 3, 4, 5, 6. Now that means that this 6th carbon has a what? It is a number 6 carbon, sorry. So it's pretty simple. We're just going to say that this is a Bicyclo bracket. How many are here? 2. 1. There's 1 carbon right here. Am I going to say 1, 2? No, I want to go from decreasing order. So 2, period, not a comma, it's a period. 1, period. How many carbons are right here in the bridge? How many carbons are stuck on the bridge? 1. So we will say 2, period, 1, period, no period, 1. So 2, 1, 1, and hexane. 2, 1, 1, hexane. What about this molecule? Again, I like to actually rewrite it with the carbons pointing out. That's just me. Maybe it takes too much time for you, but I like it. Okay, so now we redraw it. I'm going to connect the base carbons, and then this carbon is kind of like shooting upwards. Same for you, and then we're going to connect downwards. Alright, so it's like a rat trap, so that's cool. We have 1, 2, 3, 4, 5, 6, 7, and 8. So it is technically an octane, and it's shared between 2 rings. So it's going to say Bicycloalkane, but that O and an O means that you missed your bracket. So we're going to have to count our bridges. We're going to have to count our bridges. Where am I going to start? Let's say I'll start over here. 1, 2, 3, 4, 5, 6. Let's go 7. You do not go, 7 right here and then 8. Don't do that. You want to go back to your other bridgehead, climb up the ladder. 7, climb the bridge. 8. Right? So it's like a diving board. You're at the pool. Here's the water. Right, and here's like the kind of like the walkway. And these are going to be ladders. So that's cool. It's a rat trap, and it's also a pool. Alright. So it is octane, indeed. And now we name we're going to count our bridges. So that's 1, 2. That is 1, 2. And that is also 2 right here. 1 and 2. So overall, you will have what? Let's actually make this a bit complicated. Let's do this. So I want you to be familiar with substituents. Let's say that this is a CH3. So what's a CH3? Oh, well, actually it's a methyl. So we have a 2-methyl. We have a 2-methyl. 2-methyl Bicyclo bracket 2 period 2 period 2 period or no period, sorry, what? Octane. And so those are all my examples for cyclical alkanes and bicyclical alkanes, both with one substituent, two substituents, and maybe like more, right? So you learned that whenever you're naming these kind of molecules, it's better to draw out your carbons and then count how many carbons you have, and then start numbering from the bridgeheads. So this is a bridgehead, and that's a bridgehead, and this is your bridge right there, right? So we're going to take the longest path, go back to one bridge, and from that bridge we're going to go back to where we came from, and then we're going to count our shortest bridge. After that, you're going to number the brackets from decreasing order, so 2, 2, 1, or it could be 2, 2, 2, or 3, 2, 1, right? We do not increase the order, we actually decrease the order. So I hope that helps. I hope that you become a master at bicyclical and normal cyclical alkane nomenclature. So, hope you do well on your exam. Thank you for watching.